We're back again for our research and community gathering. This time we're at the newest end of our faculty spectrum. Since Caleb joined us, coming from the University of Michigan, he usurped the previous newest faculty members' roles, sitting over there, the two of them. And I think pretty much everyone knows him from the many talks, not the many talks, the talk that he gave last year, or less than 12 months ago. Yes. We're still getting a chance to know him. And today we're going to be hearing work that is newer than the talk that we heard last time. So it's exciting, good stuff that's going to be built up into other presentations and publications in the coming time. So an exciting component of this sort of thing for us is to get to hear the ongoing research of our community members. So I will turn it over to Caleb at this point, a learning-based perspective on abstract representations.
All right, thanks, Ed. I was told I have anywhere from 5 minutes to 2 hours. So we'll aim for 45 minutes and see how that goes. All right, so I'm going to start this talk with a couple pretty simple morphophonological analyses, hopefully, aided by some color coding. So I'll start with one from Dutch, where I've got 3 different nouns in both the singular and the plural form. And if we were to start analyzing this, first thing we might do is look for some patterns and see that, for example, the plurals are ending in schwa n, whereas the singulars are not. So one route we could start going down is to say that maybe the form of these 3 nouns is their form, the root form is their form in the singular. So we'd have bet, part, and pet. And then schwa n would be the plural form, in which case the singular form is just the root, and the plural would have to be the root plus voice the final obstruent in the root. But that's not going to work for pedon, which is peton in the data. So we could go down another route and hypothesize that actually the roots are their forms in the plural. And then the singular would have to be the root with final devoicing, and the plural would be the root plus schwa n. Okay, so this analysis would work. But in making this move, essentially what we're doing is we're setting up some underlying category for these final duh sounds. Because really now, duh doesn't mean duh, it means it could be duh or it could be tuh, depending on the phonological environment. Because in the singular, when it's in final position, we have tuh, but in the plural, when it's not in final position, it could be a duh. Okay, so now, essentially we need to learn we'd have to also have some mapping between this new meaning of duh, which could be a duh or tuh, and which one is actually going to be on the surface based on its phonological environment. Another case, here's some 4 nouns from Turkish, and I'm giving just the plural forms, but I'm giving you them morphologically segmented. And this one's probably even easier. Sorry, I meant to go forward, I went backward instead. We could set up an underlying representation here for the plural, where we sort of have some underlying category for the vowel in the plural suffix that can be realized as a back vowel or a front vowel, color-coded green and gold here. And this is kind of similar in flavor in that now, if we've moved to this sort of abstract underlying form, we have to then map that form to its multiple surface realizations based on the phonological environment. Okay, so this is potentially familiar to anyone who's done sort of introductory phonetics phonology or even interlinguistics. But this sort of analysis using some sort of underlying representation has, in some cases, been criticized. And I'll summarize some criticisms of these as being underlying representations as being wrong, redundant, indeterminate, insufficient, or uninteresting, as summarized by Larry Hyman in a 2018 article. Interestingly here, Hyman is not arguing against underlying representations. He's arguing in favor of them in this article, but is trying to do justice to the arguments against them, summarizing them in these ways. All right, so let me give a couple examples of what sorts of issues you might run into that sort of has just a couple examples. I'm not going to go into all of them. But one of them, again, I'm taking examples from Hyman's article, is this homophone metal and metal. So because of flapping, we have a flap in metal, in both metals. But we might want to we could posit some underlying form for metal with a T, where we have an underlying form with a T, and the metal with a D with an underlying D, in order to capture their connections to metallic and medallion. Okay, so, but it's not clear whether like a speaker of English would know these or would think of these connections. So do they actually have this generalization across the lexicon that we're insinuating by proposing this underlying form? A more dramatic example is from Chomsky and Hulley's SPE. I think this one's kind of famous, of being resign, positing racing as the underlying form with a little rusty on my SPE notation to remember what the equal sign is, but they're trying to capture here a connection with resignation, and also presumably with sign and signal. Okay, so this is like, I've been speaking English my whole life, and when I say resign, there's no connection I'm drawing to sign and signal. So it's sort of shenanigans like this that, in my understanding, led to the abstractness debates of the 1960s and 70s. And Hyman in his article summarizes it like this: as part of the abstractness debates of the period being 60s and 70s, the question posed by Leitner in setting up URs was where to stop. And I think these kind of give an example of that. One other possible problem with underlying forms I would like to bring up is that, before I get to that, right, I have to get to Hyman's arguments in favor of them. So Hyman argues that a solution, essentially, based on a number of criteria that we ought to consider when doing a particular phonological analysis. So we would be justified in setting up abstract underlying forms if they meet the following criteria. First of all, they're not overly abstract, so we don't get too carried away, I guess. They allow for parsimonious characterization of phenomena, but at the same time, they don't lead to unintended side effects. So they explain what they are intended to explain and nothing else. And then there should hopefully be some correspondence between what we're positing as the underlying representations and what speakers of the language actually know. So this one other issue I want to raise is that, at least in generative linguistics, acquisition has sort of been thought about as discovering a target grammar. And under this perspective, abstract representations are then essentially hidden structure, because there's some sort of structure that's in the target grammar that then the learner has to figure out or discover, which means that abstract representations can present an acquisition challenge. But I'd like to suggest that on the flip side, if we think about acquisition as just sort of becoming an effective languager somebody using language, then we know that abstract representations can capture generalizations. That's what we were doing in the first examples. We were capturing generalizations across the lexicon. And generalization is quite important to language acquisition for reasons we'll get into in a minute. And so from this perspective, the learner it might be advantageous to the learner to set up abstract representations in some cases to be able to effectively generalize. So this talk is going to be trying to take this second perspective and see where that leads us. I was toying with different titles for the talk, and I initially had the title "How the Input Matters," how emphasized. The idea I was trying to capture with that tentative title was that the character of the input, the language that the learner is acquiring, ought to influence what representations the learner constructs, which I think is probably fairly obvious. But if we're going to go down that route, we would need a theory of how the input matters. But I thought that title was a little too broad. This is a little bit more narrow than that question. I also thought of whence the underlying forms. The idea here being that we have, there are lots of other models, including some of my own, that are about learning phonological alternations that assume underlying representations. And a lot of other work sort of just sidestep the problem by focusing on phonotactic learning and not alternation learning. But if we're going to assume underlying representations in other models of learning alternations, then we need some better justification for them. But I was uninspired by that title, so I ended up with a learning-based perspective on abstract representations. You can choose what you like best, but all right. So I'm going to start. I'll give an outline here of what I'm going to talk about. First of all, I'm going to give some relevant empirical conditions to acquisition, just 3 of them. And then I'm going to propose a model for learning underlying representations or constructing underlying representations, depending on how you think about it. And I'm going to apply that model to 2 case studies. One of them is going to be case of systemic vowel harmony in Turkish. And spoiler alert, in this case, the model is going to be driven to set up abstract representations for some morphemes. Then we'll turn to a case study in Dutch noun voicing alternations. And in this case, the model is going to do the opposite thing. And essentially, the alternation will be a small enough part of the developing linguistic system that abstraction is not needed. Okay, so sorry for the spoilers, but that's where we're going. And then we'll conclude after all that. All right, so a couple, 3, I guess, empirical conditions of acquisition that I think are relevant. First of all, is that across a lot of languages that I've studied, children appear to know a big chunk of their morphophonology by the time they're 3 years old. And we know from other cross-linguistic studies that children at age 3 tend to know something on the order of a few hundred word types, maybe upper bounded by 1,000, something in that range. So the conditions that we'll be looking at in the case studies are going to be conditions where we're learning over roughly hundreds to 1,000 words. And then the third one is that most root forms of a word will only have a subset of forms attested in the input. And this one I'm going to dwell on for a minute, though I think I talked about it in my job talk too, but you've got to see it again. So this is because of the Zipfian character of the linguistic input. So the implication of Zipf's law is that a few words, in any sufficiently large linguistic corpus, a few words will occur frequently, but most words will occur infrequently. And so I've got this little toy paradigm table from Turkish, which is a highly agglutinative language. I've got 5 noun roots and then 3 possible forms. There's many more possible forms of nouns, but I'm just giving you 3 as a little sample. And because most words occur infrequently and only a few frequently, then for most of these possible word forms for any given root, they're going to have no or limited attestation in the learner's input. The upshot being that because of the sparsity of the input, the learner really needs to generalize. Here's a cartoon illustrating the point from XKCD. Here's a child. Wait for the screen to come back on for a second. Okay, here's a child who's just learned a 12th word. And if you count the words here in this expression, there's 12 words there, right? And yet here out pops a fully well-formed 12-word sentence immediately after learning the 12th word. Okay, so this is, of course, hyperbole, but I think there's an element of truth here in that because of the sparsity of the input, children are essentially, the productivity of the linguistic system they develop far outpaces the input, though this is an exaggeration at that point. Okay. So the one last relevant point is that while generalization is important to children because of sparsity, alternations have the potential to foil generalization. And I've got some more Turkish nouns here again to illustrate. So given our initial hypothesis earlier that plurals are formed by adding schwa n, we could just form a generalization, plural equals the singular plus schwa n. But because of the alternation, that's not going to be true for bed and horse. And so this alternation essentially is introducing exceptions against this initial generalization, foiling it. Similarly, in Turkish, if we were to posit that the plural is equal to the root plus the, say, the back vowel form of the suffix, the front vowel forms will be exceptions. All right, so to summarize, sparsity necessitates generalization, but as we've seen in these examples, positing some sort of underlying representation that's not surface faithful, right, can capture generalizations across the lexicon. So my proposal is that learners construct abstract underlying representations when surface faithful ones or concrete ones prevent effective generalization in a way that'll make precise as we go. All right, so I'm going to give a little sketch of the learning algorithm capturing or encoding this idea. But first, I'm going to describe its input and output. So the input is going to be some morphologically analyzed surface forms. An example given here, bed on with bed plural, which so it's morphologically segmented, but then there's also a gloss specifying what each morpheme is. And I have some ongoing work looking at not making that assumption, so simultaneously learning the morphological analyses. But for purposes of today, we're going to assume the inputs are already morphologically analyzed. And then it's going to output a whole bunch of things. The first thing is going to output an underlying form for each morpheme. For example, schwa n for plural and bet for bed, or something like that. And it's also going to output some morphological rules to put together those morphemes into words. And this is not going to be the highlight of what I'm going to talk about today. I'm going to use to learn these morphological rules a model I worked on with some colleagues at UPenn and Stony Brook. And we'll talk a little bit about it, but that's not going to be the focus. And then we have the output's also going to include listed exceptional word forms. So, for example, if the underlying form for bed is bet, then beds would, the plural beden would be an exception to that. And so to this generalization of root, plural is equal to root plus plural suffix. And so that's going to be listed as an exception, essentially memorized. Okay. So anything that has to be memorized under this, what the linguistic system develops will be listed as well. And then because anytime some sort of abstract underlying form is set up, the surface form needs to be predicted from the phonological environment. It's also going to output any phonological rules needed to map non-surface faithful URs to their surface realizations. And that too, I'm going to defer to previous work. This is what I was talking about in my job talk. So that we won't talk about much today. Okay. So that's the input and output. And here's the pseudocode for this. It's an incremental algorithm. So it's assuming that it's taking the perspective of a learner as they gradually learn new words. So for example, here's some Turkish words. Okay. And so while there are new words that the learner is learning, it's going to iterate over each morpheme in the surface form, which again, I'm assuming at this point are morphologically analyzed. So then it's just going to posit initially a surface faithful underlying representation, which is just going to be the most frequent realization of that morpheme thus far in the learner's lexicon. So for example, if the back vowel form of the suffix in Turkish has occurred more often than the front vowel, that'll be the initial underlying representation. Okay. And then if there's this quote unquote too much alternation, so enough alternation that it foils generalization, in a way I'll make precise in the coming slides, then the model will construct an abstract underlying form for that morpheme, like under specifying the backness of the vowel, and then learn a phonological process to map that underlying form to its surface realizations. Okay. Otherwise, if there's not so much alternation that it foils generalization, then the exceptions can be lexicalized. All right, so that's the pseudocode. I'll go through an example in a minute, but I first want to define what too much alternation means. And to do that, I'm going to use the tolerance principle, which is proposed by Charles Yang, and it evaluates some linguistic generalization, which we'll just call R, in terms of two numbers. The first is N, the scope of the rule or the generalization, which is just the number of things it makes a prediction about or applies to. And the other number is E, the number of exceptions to the generalization, number of things that just don't follow it. And then the tolerance principle states that R, this generalization, is productive if and only if E is less than or equal to this apparently not magical, though it's not magical, threshold N over the log N, natural log of N. So you might ask, where does this threshold come from? I'm not going to give the derivation here, but I will mention briefly that this is derived from the analytical Zipfian distribution. So it's grounded in the same empirical conditions of acquisition that I described earlier. And I'll give a little bit more justification for this in a moment. But I want to first give an example of it. Suppose we have the generalization plural form equals singular form plus schwa n that we've been using as a toy example. Over these 5 nouns, the rule makes 5 predictions. So n is equal to 5. But 2 of them, because of the alternation, are exceptions to the generalization because they're add schwa n and there's a voicing difference. But 2 is less than 5 over the natural log of 5, which is 3.1. So that's a tolerable number of exceptions. Okay. On the other hand, in most cases, you're not just going to have sort of like one rule that applies over the whole set of words that the learner knows. And so this is where the model I mentioned earlier that I've worked on with some collaborators comes in, which is an algorithmic implementation of the tolerance principle that allows you to subdivide the words that the learner knows until a productive generalization is found. So essentially, you're getting more and more specific generalizations until a productive one is found over the subgroups you're partitioning. I'll give an example of this. So in Dutch, some nouns are formed not with. All right, so there are some nouns in Dutch that don't end in schwa n, the plurals. They're formed with adding s. And a good predictor of this is if the final syllable of the stem has a schwa nucleus, probably having to do with stress, because schwa can't take stress in Dutch. And so if you have a schwa n syllable, the suffix, then you'd have back-to-back unstressable syllables. But this is a good predictor, regardless of the reason. And so if we include a few of these as exceptions as well, then now we have 7 nouns, if I got that right. Yeah, maybe I have 8 there. I have 8. Okay, I messed that up. But pretend it's 7. Right? And 5 of these now are exceptions. And so this is going to jump over the threshold now. And so there's too much alternation. So what this model does is it subdivides based on some feature that separates these different types of words. So for example, does the syllable end in the schwa nucleus or not of the stem? And so then you get kind of like this decision tree type thing where you're trying to form the plural and you subdivide it based on whether the stem ends in a final schwa syllable or not. And then you propose different rules over each subdivision. And if those aren't productive, you again subdivide and you'll get this recursively built decision tree, which we'll see one of later. But here's a little mini one. So here then adding s on this final schwa syllable branch doesn't have any exceptions. And then we're back to the state we were at before, where we have the alternating forms as exceptions, but there's not enough of them to break the generalization. Okay. So this is how the morphological rules are going to be learned and how the tolerance principle is going to come in and as a tipping point as to when we have to move to abstract representations or not. But I want to give a little bit of justification for why the tolerance principle, why I'm using the tolerance principle here. First of all, it's precise. It makes an exact prediction about the point at which surface alternation fails. In other words, it gives you the exact tipping point, n over the log n. Second of all, its derivation is cognitively motivated. It's based on considerations of linguistic processing. Again, I'm not going to talk about those in this talk, but it does have some cognitive basis for its derivation. But also, this Zipfian or sparse input is what I'm arguing necessitates generalization in the first place, and it's also what yields the particular threshold. So it's also grounded in the empirical conditions of acquisition. And then there's a whole bunch of corroborating studies, corpus studies, acquisition studies, computational and experimental studies that support this threshold. So I think it's reasonable to use. All right, so let me give a brief example of the full algorithm now on some Turkish data, but we're only going to look at the plural suffix just for simplicity. So here is this sort of stream of words that the learner is gradually learning from top to bottom. And the learner first sets up, let's say at this stage in the algorithm, they set up LAR, the back vowel form, as the plural underlying form because it's occurred 4 out of 7 times, 4 to 7 realizations. And so any word form that doesn't have the back vowel as the realization of the plural is an exception, is going to be an exception to if plural, then it's the back vowel form. And so those have to be lexicalized. And so at this stage in the algorithm, there are 7 instances of the plural, 3 of which are exceptions to this particular underlying representation. And so that's not too many exceptions to foil the generalization. And so the generalization holds up. But suppose another word comes along. Now there's 8 words. And this one also has a front vowel. So it's a new exception. So now there's 8 words with 4 exceptions, which tips over the threshold. And so then what the model does is then it sets up an abstract representation, which requires then a phonological rule to generalize, to predict surface realization of that underlying form. But then these lexicalized forms are now predictable, so they can be removed as exceptions and captured under the generalization. So the main idea here is that this learning algorithm is meant to capture is that it's starting with concrete representations, and it's going to maintain those until the amount of surface alternation makes that a generalization from concrete representations no longer tenable. That's the gist of the algorithm. I'm going to turn now to some results, but I first want to highlight this connection between setting up an abstract underlying form and the need for a productive phonological process to predict the surface realizations of that form. Because I'm going to be talking about some acquisition results, and it's very hard, if not impossible, probably just very hard, but to probe the representations that children have in their heads. But we do have fairly good ways of assessing productivity of generalizations. And so this connection between these two is very critical, because what we can actually access is the productivity and not representation directly. So we're going to look at two case studies, which I mentioned before. First of all, the model's going to predict vowel harmony to be productive by 1,000 words in Turkish. And that's going to be consistent, spoilers, with some acquisition results that Turkish learning children are productively generalizing vowel harmony by age 3. And it's then going to predict no productive voicing alternation by at least 900 nouns in Dutch, which is going to be consistent with some acquisition findings that Dutch learners do not show evidence of productivity at ages 2.5 to 3.5 and potentially much longer. All right, so let's start with Turkish. I'm more excited about the Dutch results, but we'll talk briefly about the Turkish ones first. So I want to first characterize the input. And I've got here to start the vowel inventory for Turkish. And the most famous aspect of Turkish vowel harmony is the back front vowel harmony, which manifests most prominently in suffixes attaching to either the stem or other suffixes, and harmonizing in backness with the vowel to their left. So we see this, for example, with the plural suffix and the genitive suffix. There's also a secondary rounding harmony that only applies to high vowels. So the high vowels up here. And so that means that, for example, the genitive suffix, which has a high vowel in it, will match both the backness and the roundness of the vowel to its left. But there are some exceptional suffixes. For example, the suffix ki, which can, I'm told by the literature, attach to temporal or spatial nominals to yield adjectives, doesn't alternate. It's just always ki, despite the fact that it's a high vowel. And then there are some, what have sometimes been called half harmonizing suffixes, half harmonizing because they have two vowels, one of which harmonizes, the other of which doesn't. An example is the habilitative suffix, where the first vowel harmonizes in backness, but the second vowel, like in ki, the second vowel doesn't harmonize. And then there are some other, of course, lots of other processes going on in Turkish as well, not just vowel harmony. One example is shows up in the locative suffix, where there's an alveolar stop in initial at the beginning of the syllable suffix that assimilates in voicing to the segment to the left, while the vowel also harmonizes in backness. All right, so I'm going to run. I ran this model that I described earlier on two data sets. One is a corpus of child-directed speech from Childus, actually two corpuses put together. And the other is a morpho-challenge data set, which was, I think, from a web scrape, but it's a much larger data set, but it is not child-directed. But the results were fairly consistent on both. So this distinction is not terribly relevant here. So I'm going to first describe a few examples of the underlying representations of the model constructed for the suffixes I just described. And then I'm going to show the accuracy of the whole model predicting novel surface forms. The reason for this is because that's exactly the problem that I posed at the beginning, right? Is that there were all those question marks, all the words that are insufficiently attested in the input for the learner to know. And so they're needing to generalize to sort of predict the form of those words. And so this is testing the accuracy to sort of confirm that this account at least does the task that it would need to do. All right, so first of all, for the plural and genitive suffix, there was enough surface alternation, I think unsurprisingly, that the model set up, they foiled the generalization from concrete underlying forms, and the model set up abstract underlying forms for these two suffixes, with the plural being underspecified for backness and the genitive for both backness and roundness. But then for suffix like the key suffix where it's not alternating, there weren't any exceptions introduced by this. So that one is sort of underlyingly concrete. And then half harmonizing is underlyingly abstract, but it's only the vowel, the single alternating vowel that's underspecified, not the whole morpheme. And then the locative, there was enough alternation of both the voicing assimilation and the vowel harmony to drive the learner to abstraction here. Okay, so this predicts then that because there was enough alternation to posit underlying forms for some of the harmonizing vowels, some of the harmonizing suffixes, this predicts that learners will have productive vowel harmony. And these data sets were, these results were on data sets of around 1,000 words. So this is predicting that by 1,000 words. And there's one acquisition study I found on Turkish, which was written in Turkish. So I had to use Google Translate plus my non-linguist Turkish friend to try to decipher this paper. And it seems that by age 3, I think even a little younger, 2.5, children are showing 2 signs of productivity. First of all, they will extend it to nonce words, key sign of productivity. Second of all, they overextend it to loan words, which are exceptional in the adult language. Most of these are Arabic loan words, which are often exceptional in Turkish, so that the suffix will not harmonize with it in the expected way, but children would expect it to harmonize in the expected way, overgeneralizing harmony to these, to what are exceptions in the adult language. And then here's the results at predicting the surface forms of words not seen during training. So this is, of course, combined with the model I presented to my job talk for learning the surface realizations of these underlying forms. And we're seeing as vocabulary size increases on the x-axis for the morphophonological data set and the childish data set. And then the y-axis is the accuracy predicting held out forms. And then just for shits and giggles, I decided to run a transformer as a comparison model. This is a neural sequence to sequence model, and it wasn't as good, so I liked that. So that just shows, I guess, first of all, there was at least 90% accuracy predicting novel held out forms by 1,000 words, and it eventually surpasses 95% accuracy. Okay, so this, putting these pieces together does in fact lead to accurate prediction of words that weren't seen during learning. Okay, now the fun case, Dutch. All right, so I'm going to go over the input for Dutch like I did for Turkish. We've been talking about this the whole talk, so some of it will be review. But we've got here this alternation between, in some paradigms like bed, beds, we have bet, bedden, and then other paradigms we don't see the alternation, like pet, petten. So a traditional analysis would be that the underlying form of bed is bed and cap is pet. Pet then trivially leads to the singular and plural forms that are attested. But then the analysis would be that the underlying duh is realized as a duh in the plural because it's resyllabified as an onset, in which case it's phonotactically allowed to be voiced, whereas there is a restriction against final voicing, obstruent voicing in Dutch. And so that would predict then you would get devoicing in final position, and that would explain the two different forms. So under this traditional analysis, this would predict essentially that learners have a productive devoicing role. But children do not show evidence of a productive knowledge of this alternation. At least at 2.5 and 3.5, where, in my view, it's been studied most thoroughly, but probably through age 6 and maybe into adulthood. We'll talk about that a little bit more in the conclusions. But I want to show one of the studies that I think is evidence of this. And this is the Zemuner et al. 2006 study. It was a reverse perception-based WUG test. A reverse WUG test because in the original classic WUG test, children were presented as singular and then asked to produce the plural. So here's a WUG. What's the plural? It's WUGs. Right? So you're going singular plural. Here you're going plural to singular. So it's reverse. And then it's perception-based because they're asked to identify the singular rather than produce the singular because they're 2.5 and 3.5. All right, so here's an example. The experimenter might present a picture of some non-subject in plural form, so multiple of the non-subject, and say, these are slawden, some nonce plural. In which case, the surface-based root form would be slawed with a voiced stop in final position. And then the child is given 3 images. One is the singular of the plural they just heard. The other is the plural repeated, and the third is a distractor. And they're asked to sort of like, where is the slot, or point at the slot, or something like this. They're asked to identify it. And so there's a discrepancy between what the experimenter says, slot, and the surface-based root form in the plural for these alternating trials. So there's another set of trials then where there are non-alternating nonces. So here the experimenter says these are ketin, where it's not going to alternate then, in which case the surface-based root form is ket, and then they're asked to identify the ket. So what's expected here is if the children have a productive voicing alternation, if they can productively devoice the duh, then they'll be able to get rid of this discrepancy between slawed and slot, and so they should perform equally well at both types of trials. If they don't have productive knowledge of this, then they would not perform equally well at the 2 trials. And children at 2.6 and 3.6 perform much better the non-alternating nonces than the alternating ones. More consistent with the second hypothesis. All right, so some details about the Dutch input before I describe what my model does here. Dutch actually has 4 possible forms for nouns. There's not just a singular and a plural, but there's also the diminutive and the diminutive plural. And the alternation only shows up in the non-diminutive plural. And this is, I think, hugely significant because we know that child-directed speech tends to disproportionately show diminutives, more likely to say horsies than horses, I guess, the kids. And in fact, in corpus studies of Dutch, the diminutive plural of many root nouns is more frequent than the non-diminutive plural. And so for those nouns, you're going to have limited or no attestation of the alternation, even if it's an alternating paradigm. All right, also, some plurals take s, as I described before, instead of schwa n. All right, so to summarize this, only some nouns take schwa n, others take s, and if it takes s, it can't alternate because there's no new syllable. And then only some of the nouns that take schwa n alternate. So for example, not pet, petten, but also not anything that ends in a sonorant. And then of the forms that do alternate in the adult language, you have to have seen the non-diminutive plural and some other form to even see evidence of the alternation. All right, so maybe the idea is that Dutch learning children lack productive knowledge of this voicing alternation because it's just not a very important part of their developing linguistic system. And this is a hypothesis that I think my model makes precise via the Tollage principle. So here's the decision tree of morphological rules learned by the model on 887 child-directed nouns. This is like falling off the edge again, but I think you can see enough of it. So this is trying to predict the forms of all sorts of different types of nouns, not just the plural. So I want to highlight the one that's relevant is this branch. So each leaf of the tree can be thought of as a rule. And so this one highlighted now is for if I'm trying to form the plural non-diminutive of a noun stem that doesn't end in a schwa nucleus, which are the ones that take schwa in. So that's where all the possible alternating forms are going to fall. And I've shown in ordered rule form the same rules, along with their tolerance principle counts, and highlighted at the top the relevant one. So there are 90 nouns that fall under this branch, only 10 of which are exceptions. Turns out 8 of those are due to alternation, 2 of them were other things. But 10 is well under the threshold of 20. And so there's this generalization holds up without ever positing any, and you can just lexicalize the alternating forms as exceptions. Right. So to drive this point home, here's a comparison for what it's worth of the performance of kids on this reverse lug test to the model predictions, and then I'll talk about the trigram for a second at the end. So kids were much better than non-alternating conditions, where you had ket and ket, and there's no discrepancy, than they were at the alternating, but they were quite bad at both. And the model, of course, is a machine, so it's going to do categorically, but it's when the form does not alternate, the surface faithful root form is consistent with the singular, so it always gets it right. And then it never gets it right for the slot in slot. The reason I have 0.33 is I'm just saying if there's a discrepancy between the surface faithful form and the predicted form, then you just guess out of the 3 possible pictures. That's how you get 1/3. So the numbers are off, but the direction of the trend is right. And I think that's quite significant because if we look at a trigram model in comparison, so this is run on the same child-directed data, but because, and it's evaluated based off given ketin, is ket or ked higher probability? If ket is higher probability, then it gets it right. Otherwise, it gets it wrong. Likewise, for slot in and slot, if slot is right, so if the form that the experimenter says is higher probability, it gets it right. And so because of the phonotactic restriction, the voiced obstruent never occurs in final position. And we get, so the trigram does essentially uniformly across the board. So this is illustrating how even if you know the phonotactic restriction, that does not imply that you know the alternation. And this seems to be the case with kids, because kids never produce, Dutch learning, monolingual kids at least, never produce final voiced obstruents. So they seem to know the phonotactic restriction maybe, but they don't seem to know the alternation. All right, and then the model can still predict novel surface forms, achieving 94% accuracy on 700, trained on 700 nouns. So even though it's not setting up any abstract underlying forms here, it's able to still accurately predict novel nouns. So just to conclude, we saw that the proposal here was basically that we're going to take a learner's perspective, and that means that the model is going to change representations from a surface faithful form to something more abstract, if and only if it's needed, if alternation foils the generalization from concrete forms. And so we saw then that the systemic character of Turkish vowel harmony led to abstraction for some morphemes, but then for Dutch voicing alternations, they formed a small enough corner of the child's developing linguistic system that they didn't need to set up any abstract underlying forms. They could just lexicalize this exceptions instead. Here's a diagrammatic characterization of the same thing I just said, essentially. But I've got this extra column for successful prediction of novel surface forms. Again, tying it back to the original problem, which is that children's linguistic systems have sort of productively extend far beyond the actual input that they have. So that means that that suggests that they can predict sort of novel forms. A couple lines of future work, I think, with both of them having to do with Dutch. One is, what about adults? So I need to look at the literature on this a little bit more closely and see whether adults do really, if I'm convinced that they show evidence of productivity, and if so, when does it emerge? So I think there's two possibilities. One is that if eventually Dutch adults do have productive knowledge of the alternation, that eventually there's enough alternating forms in their lexicon that it sort of drives them to abstraction under this model. So I can evaluate that by running this on like CellX, which is a larger corpus than what I had with child-directed. The other possibility is that they learn it via orthography, because the alternating forms in most cases have a voiced form orthographically, I believe, in the singular form. So if you have bet, beden, and so that shows you, that could indicate that the discrepancy between the heard form and the seen form could be a cue to the underlying form. And then the other direction would be to look at a comparative study with German, which I'm quite interested in. This was inspired by a paper by Buckler and Fickert, because German makes the same voicing distinction. This has the same sort of voicing alternation as Dutch, and they're genetically quite closely related languages. But German makes a voicing distinction over a larger range of obstruents, and in corpus studies, a substantially higher number of nouns alternate in German than Dutch. So I'm quite interested to see if there's actually a difference between these two languages, and that you do get the productive knowledge of the alternation in German, but not Dutch, which would mean I need to model this, but also find some, run the experiment as well. So those are a couple of directions for future work. And I went over my 45 minutes, but I stayed within my 2 hours. So stop there. Yeah.
Well, thank you. So the question that comes have you tried this classic morphology? When plural nouns are not as something that they plural markers are not suffixes or this is they change to the roots of the.
So for those of you on Zoom, the question was whether I've tried this on anything with templatic morphology. And the answer is no, I have not. But I thought about it, but I haven't done it. Well, I just don't know.
The question is like, will the model as it is work or
certainly the code wouldn't work as it is. It's because it's assuming concatenative stuff. But whether it might be the case that I don't know what extensions exactly would be needed for it. Yeah, but it wouldn't work as is without changing at least something representationally. Right? There.
I think you might have this when we talk about the paragraph model. But I'm curious about how essential applications are for the model. So I'm thinking of language like Thai, which has similar final voicing that doesn't have suffixes, so it's a static generalizations. You don't get all of these roots. What would your model predict about a language like that? How important is it to have actual applications?
Okay, so the question was about Thai and how critical alternations are, Thai being relevant because there are, you said there's...
It has final devoicing.
Has final devoicing.
No final voiced obstruents, just like Dutch.
Yeah, as a static phonotactic restriction.
Yes.
But it never shows up in alternations. Yeah, so if it never shows up in alternations, then this would essentially predict that that's not that learners, I mean, learners may for other reasons have sensitivity to the phonotactic restriction, but this would predict that they wouldn't necessarily productively generalize it to novel words. So I guess if you took nonce words with final voiced obstruents, although I don't know how you would design an experiment to test this, but I think that's a prediction that it would make, is that you would not have productive knowledge of devoicing, although you might have, for other reasons, knowledge of the phonotactic restriction. So you'd have to do some clever experimental design, I think, to figure out, to tease those two apart. Because I think people would respond better to words that Thai speakers would probably respond better to words with final voiceless obstruents than voiced ones, just because they probably are aware of the phonotactic restriction. So I'd have to think about what the experiment would look like, but that's, I think, the prediction the model makes. Yeah. Ed.
So one thing I like about the point at which
right.
But I'm interested in this connection to development of U-shaped curve,
right,
which is really short time.
Yeah.
And you know, like whether you would want to conceive of a relationship between those two things as due to a short-term observable period in which there's indecision about abstract creating or splitting into subsets versus something about memory storage, previous forms, switching.
Yes.
Rid of.
Yes.
But again, I still think it took time.
Yeah. Okay, so I'll speak to. So the question was, in summary, how does the tolerance principle and its precise threshold of n over log n relate to U-shaped developmental trajectories like you see in English past tense, where children go through a stage where early on they produce irregular verbs like run, ran, consistent with the adult forms. And then they go through an over-regularization stage where they start saying run, runned, applying the sort of default add D. Okay. Or rand, okay, at times. But still over applying the generalization of add D, or one of its allomorphs. But and then they sort of correct, giving you a U shape in accuracy compared to the adult form on irregular verbs. So this paper, this 2021 paper I cited as the model that implements this, I won't go to the citation, doesn't matter, but that paper, we actually modeled that exactly. That was one of the two things we studied. There was that in German nouns, not this example of German nouns, but something else. So this actually is, I think it's perfectly consistent with it, because what happens is you get, so in the early stages, there's nothing productive. And so everything's memorized. And then at some stage, add DT or UD happens to be, it becomes productive, at which point you overgeneralize because you have a rule now. And then you have to backtrack and learn all of the exceptions lexicalized. So I think it's fully consistent with this. And I don't think the timeline is perfectly mapped of when that U-shape happens, but we did model the U-shaped trajectory, and we do get that U-shaped trajectory to a certain reasonable bounds of expectation. Because this threshold is never permanent. So it's never like, once you pass that threshold, it's not like you can't go back. It's like maybe the generalization. So we, this paper, 21 paper was a CogSci conference paper, and we're working on a journal version, which is incremental, fully incremental, to capture that idea that you have to backtrack in some cases. Yeah. The flipping is not necessary to the U-shaped curve in the English past tense, but in some cases you may have to backtrack. And so I don't think in this case backtracking is a situation, but
German plurals.
right.
But also then to capture the I guess first one test lower frequency. So like S.
Right. Yes, that's what it is. Right. So yes. Let me just say what I know on that. So okay. So the question was on German noun plurals, referencing again this CogSci paper. That because we did a case study on English and on German. And so we're looking at German noun plurals, of which, unlike Dutch, which has, I think, just 2 forms of the plural, there are 5 forms of the plural. And they're quite nuanced in sort of what very small corner of the noun system the suffix applies to. The nonosphere. And so there's been, I think, multiple analyses of these. One is that they're essentially none of them, or not all of them, are like fully productive, and that they're sort of gradiently productive. What this model predicts is not that they're gradiently productive, but they're productive over a subcategory of the input. And so you get this very complex decision tree that partitions the data into fairly specific nuanced classes, and then you get productivity for all 5 suffixes. And we did actually get, we didn't have enough data to get this consistently, but we were getting S as like the bottommost suffix. So it's like the default, which is what it seems to be in German, because when loan words come in, you have iPhone, iPhones. I think it's the evidence of that. Yeah. Yeah.
So
Yeah.
Plural suffix alternates not just in vagueness and height. So the front counterpart will be so
okay.
Right, has to, yeah, so you have to,
in which one?
The
plural?
There, plural.
Okay.
I'm wondering if the height alternation, which is kind of orthogonal to harmony, that complicates the learner able to model this task, or is it just or taking one or both of those, just say it's the height alternation, you're able to set that aside.
So are you saying phonetically it does, or phono? Like I'm not, because aren't they in the like the inventory I gave here, which is the one I always see, the 2 forms are both low vowels. So to make just a minimal set of features that separates the vowels, they're both low vowels.
That maybe I've always understood it as there being no actual front of the part of that.
Okay.
So
yeah. Okay, so the question was on Turkish plurals, that maybe the low vowel, the front vowel is mid instead of low. And so you have between the back and the front vowel a difference in height, as well as a difference in backness. In which case, that's going to depend on how I'm representing this featurely as to what implications it's going to have. So if it's viewed as like, we're just going to match the backness, then this would have to be captured by, in that case, you'd have to match both both the height and the backness of that particular suffix, and any other suffix that only harmonizes on those 2 vowels. And then you'd have to have a separate one for if you've got, say, the high vowels, which don't alternate on height then, but do on backness and roundness. So it's going to be another distinction like already is there for the high versus the low vowels, where you have to have a primary and a secondary harmony aspect. But the way I implemented this was I was going off of this feature representation where you have a high-low distinction, but not a mid distinction phonologically. But that would be the adaptation needed if we were to change that. Yeah, Daniela.
So you should have with your learners category also you get the direction of the thought, but not
right.
You're not attempting to model the boundary.
Right.
So I'm wondering whether you think that's, I'm a big fan of polyglot learners, so I have no problems with it. But I'm wondering whether you think that's, something that you will easily get by already programming things in it, or so I have a technical question and a conceptual question. The technical question is how hard you think it would be for you to go in a direction where you can model the conflict. And the conceptual question is whether you think that these kind of differences tell us something about representations, or they are, in a formats kind of out there.
Yeah. So the question was in these results in this table, my model is categorical, and so it matches the direction of the trend, but the numbers aren't really very close. And how feasible it would be to go in the direction of making it more accurate in some way, and then also, what was the second aspect of it?
Well, the second aspect is whether it's very interesting.
Whether it's interesting to go in that direction. Yeah, I think about this almost every time I do a paper, because I'm constantly comparing to experimental results, and I always have categorical models, and then they don't quite match perfectly for that reason. So I don't know. I almost feel like there has to be a model of the experiment on top of a model of language. And rhetorically, I feel like that's beneficial, at least rhetorically, because I get sometimes somewhat shocked responses from the audience when I present categorical results on something that, when in an experiment, people are clearly not categorical. I really have a hard time knowing why, or even conjecturing a guess as to why the results are like these particular numbers for kids. And what part of that is like the kids getting distracted in the experiment, versus what part of it is maybe indicative of something about the nature of their representations. So I don't feel like I've answered your question. I guess I would like there to be a way to do it, but it's not immediately clear to me what it would be. I could just inject randomness, be like, oh, sometimes because I can run the model like multiple simulations and pretend like, okay, this time the model gets this amount distracted. But then I'm essentially making a theoretical stance about the experiment that distraction's at play here. And so now I'm making two claims instead of just one. And
I mean, the other way is that you could, that could be, I mean, it's the same concept for you. It's just easier to justify to the other game, which is playing with, you get the representation that's more gradient in some ways. So, well, if that gets the model correctly, then
just introduce gradients into my model's representations. Yeah.
And so just because conceptually that's easier than coming up with that theoretical model of the experiment. Well, maybe not easier, but easier to justify. That's the people who buy positiveness.
Yeah, I feel like that still makes another prediction, or a theoretical claim.
But you did ask a question.
Yeah. Okay. Good.
How many words do we need for corpora?
The question was how many words were in the corpora. So in the Turkish data, it was when I was reporting the underlying forms, it was mostly on most of the stuff was on about 1,000 words. The exception is the results I showed with the accuracy here. The larger data set went up to 3,000. And then Dutch was the full model I showed here was this result was on the full corpus of 887 nouns. And then the accuracy here was on 700 nouns. But I also ran simulations on various sizes to just confirm that like there's not some substage at a smaller size where the alternation becomes productive, and they're consistent was not across simulations at smaller vocabulary sizes as well. So it's up to at least 887 nouns. Absolutely, yeah. I don't remember.
But clearly, if there is, as you increase the number of
Right.
If
Right. Right. Yeah. So this question / point was on this probably could make historical language change predictions or explanations. Explanations is better because you can't really make predictions about history, but explanations about history. So yeah, I think that's absolutely correct. And it's a direction I'm actually quite interested in. I don't have the background in historical linguistics. I've been reading about it lately because I find it very interesting. Yeah, because I think it's widely recognized that acquisition has a role that plays in language change and it's sometimes viewed as like, well, there's the target grammar, which is the adult grammar. And then if you make an error and you fail to converge to the target grammar, then you get language change. But there was another way of looking at it is, well, the child's just constructing their own linguistic system and it's influenced by the input. So invariably it's going to look kind of like the input, but it's not necessarily going to be equivalent because they might come up with a different system. And so here's an example where like the voicing alternation, again, I think this is another reason why German and Dutch is interesting because they're closely genetically related. And so you could see something where like there's a regularity in the language, this alternation, but at some point that regularity was just lost from the sort of productive linguistic system of speakers. Right. Yeah. Functionalist explanations. Yeah.
but it could also sense data at a
Yeah.
point close to the threshold.
Yep. Yeah. 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 Yeah.
Next week, we'll be back. Time. to hear from Matteo.